Hello, Mr. Ryan, are you right?
No.
Okay. We're given n integers. We're given a list of integers from 1 to n. Integers. 1 to n. And we call this array of integers semi-ordered. Okay, what's semi? Semi means the half, right? 50% order. Semi-ordered. Ordered permutation. If the first element is 1, last element is n. With one operation, what you can do is that choose any two adjacent numbers and swap it. So you can pick two numbers, neighboring numbers, and swap it. So the question is that what's the minimum number of swaps in order to make it semi-order, which is the first number is 1, the last number is n. For example, given this, what's the minimum swap?
So it needs to be 1, 2, 3, 4.
No. The first element should be 1, the last element should be n.
What's n?
N, 4 in this example.
3.
Why is it 3?
You need to swap the 1 with 3 and then the 4 with 3. And then 2.
Okay, so you can pick any two numbers and then swap it. And then the target is to make the first number 1, the last number 4. So how do we do it?
We just swap the 3 with 1.
3 and 1. No, you can't because this is not neighboring.
So
You can only pick two numbers.
Swap 4 with 1.
Yeah, that's one swap. And
then you swap 2 with 1, I think.
okay, so 2 and 1, so 1, 2, 4. Okay.
And then you swap 1 with 3.
Okay, so how many swaps? 3.
Yeah.
Okay, so given another one.
So basically you need to find how far is it from the beginning.
How far? Okay, so
and then subtract the number is by
okay, so 1, 2, 3, 4. How many swaps?
0.
0 because it's already
In the
semi-ordered.
first place and 1 minus 1 is 0.
Okay, how about 2, 1, 4, 3? How many swap?
1, 2.
2. Here and here. So this is 3, this is 2, this is 0. Okay, so what have we learned about it? So given an array of integer which contains the number from 1 to n, how do we find out how many swaps, the minimum number of swaps?
On the last one we need to swap the 3 with 4.
Because we want to get the last one as the 4 and this swap. Okay, so 2 swaps. Do we actually need to swap to simulate the process?
No.
No. Okay, that's good. Why?
Otherwise why would you ask? Yeah.
Okay, so given this, given a number like 2, 4, 5, 100, right? Suppose n is 100.
But you don't have 1.
12, 13. Okay, that's it.
But you don't have 1 in it.
Okay. Ah, yeah. You're right. Okay, so let's say we have 1 here, 2, 4, 1, and then a lot of other numbers here. And then the last number n is 100. How many swaps do we need?
4.
1,
Yeah,
2, 3, 4. Okay, yeah, you're right. And how about if 101 swap the places?
You don't know, you said and a bunch of blah 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 blah.
Actually, we can work it out.
8.
Because look, 100 numbers.
But you said there was
8.
a bunch of numbers.
Yeah, a bunch of
8.
numbers.
Yeah, I don't know how much is that bunch of numbers. 8.
A bunch of numbers. Okay, so let me
How
do it.
much is a bunch?
So-
we don't know how much is a bunch.
Overall 100. 100 numbers. So 2, 4, 100. Some numbers here.
What are
5,
the numbers?
1,
Yeah, what
12.
are the numbers?
It doesn't matter.
It does.
How many numbers? 1, 2, 3,
How
4,
many
5.
numbers are in the gap?
I'm saying there are total 100 numbers. So how many numbers here? Can you just not work it out?
93.
Okay, 93. Okay.
How is that 93 numbers?
Altogether 100 numbers. 1, 2, 3.
But that's so
4.
little. That like
Okay.
only
Just imagine there are 93
that
numbers
only
here.
could fit like
Okay, so how many swaps?
that could fit 3 numbers.
How many swaps?
None.
How many swaps? So how do we work out?
93, 94.
Okay, so let's say
97,
how many swap to make
98,
100 to the last one?
98, 98, 101.
If this is A, how many numbers from swapping one? How many numbers
194.
swap to this if this is B? So what's the answer?
194. Yeah. That's the answer.
194.
Yes.
How did you work it out? Oh, okay, so how many swap to get 100 to the last?
Let me count again.
Okay, so let's say this is just A times, and this is B times. So how many swaps? Okay, what I'm saying is that it takes A times to swap 100 to the last, and it takes B times to swap 1 to the beginning. So how many swaps in order to get 100 to the last place and to get a 1 to the first place? So it's A plus B and
plus 1. I'm just guessing.
let's consider this, okay? 3, 2, 4, 1, right? This example. Actually, 4 here. 3, 4,
Doesn't matter.
3, 4, 1, 2. Okay? We want to get the 4 to the end, let 2 swap. We want to get the 1 to the first one, 2 swaps. So the answer is, how many swaps?
4.
Why is it 4? Okay, so how do you get the 4? Come on. I want you to figure out what's the problem here.
Oh.
Oh, do you see something here? Can you tell me how to swap 1 to the beginning? 4
3.
Yeah, why is it 3?
Because when you swap 1, 4 is also swapped.
That's right. Okay, so that's very important. So here, A plus B minus 1. Because they're crossing. So when you swap, you at some point, when 100 is here, 1 is here. When you swap it, you don't need the 2, right? You just need 1. Am I right?
So is it 197 or?
Okay, I don't know the number, but that's the thing. But this is one case. Another case is that if it's not, so for example, like 3, 1, 4, 2, okay? So look, we just need to swap these here
No, 2.
and here, right? So look, these are 2 separate. It doesn't cross. So we can just get these to the last and these to the beginning. So this is A, this is B, so it's A plus B. But do we actually need to do the swapping?
No.
No, we don't need to do the swapping as long as
Why
we...
would you ask?
What do we need to find out the answer?
A plus B.
What's A, what's B? What's A, what's B?
That thing in the jiggy.
What's A, what's B here? What's A, what's B? What's this thing? We want to find out
what A is A wait A is N to the end and B is 1 to the beginning.
Okay, so we want to find out the what of the number. Number 1 and number n. We want to find out the what of the number. Can you complete the sentence? We want to find out the what of the number 1 or n.
Triangle.
We want to find out this
This
A, this B. So what's this A, what's this B? And this is obviously only 1 and 4 are important. The rest numbers do not matter, right? The I, N,
Integer.
D,
Index.
index. We talk about index and find function, remember? Do you still remember? Index and find, right? When we find, if we don't
Value.
find it, we don't find the index, it returns the minus 1. And
It returns the.
And if index do not find it, it returns an error. Okay? So we want to find out the index. As long as we find out index, then we compare. Right? We compare. Yeah? Or the position. We want to find out the position of the number 1 and the position of the number 100, the n. The index of the first number and the index of the last number. Define mean swap. We given the numbers A, R, R. A equals ARR, the index, right? The index 1. B equals ARR, the index n. What's n? N, let's say n equals the length of the ARR, right? Okay. Now we got 2 index. The index of 1 is A. The index of n is B. How many cases do we need to check? How many cases?
2.
2. One is if A is smaller than B, then what do we return? For example, this is the number, right? If the 1 is here, this is A. B,
A plus B.
we want to find out that this is B, but the B return is this bit, right? This is B. This is A, this is N. This is 1, this is N. The index of N is B, the index of 1 is A. So what's the answer? We want to find out this bit, right? What's this bit? Overall, this is N, right?
N minus B.
Yeah, but the index starts from 0, so it's return.
Why is there
A.
2N?
Sorry?
There's 2N.
Good question, good question. This is actually the number N, okay?
That's no question.
Okay, this is a good point, okay? So A plus N minus 1 minus b. Okay, n minus 1 is the last index, minus b, so it's this bit. Yeah, so it's just a plus b here. Okay, else return if this is b, if this is a and this is b, so what's the answer?
A plus B minus 1.
Yeah, so it's this number.
Minus 1.
Okay, so it's a plus n minus 1 minus b minus 1. Okay, this is the just only one.
Like minus 2.
Yeah, of course, yes. The time complexity.
On.
Yeah, on. Finding the number in an array, on. Okay? Space complexity, O1. Space complexity, O1. Finding the numbers. We need to find out that number twice. Okay, finding the number twice. On, O1. Okay, so what have you learned today?
Learn about this.
So what are we doing with these numbers?
And then we want to swap 1 to the beginning and the end to the
last, yes.
We don't need to do the swapping.
Instead, we need to do...
Calculate like A and...
Okay, so what's A and B?
A is like... I forgot which one or N. And
Yeah, it doesn't matter.
To the beginning and N to the end.
Yeah, the index, right? We use the index function to find the index where the position, the number, the element appears in the array. And as long as we have these two index, and then we can calculate it. And there are only two cases. The first case is the first element, the 1, is before n. The second case is that the n is before 1. Yeah. When n is before 1, when they cross each other, we save one swap.
Yeah.
Okay, that's it for today. Bye-bye.
Bye.
Bye-bye.